Is this evidence of the presence of one more universe? For north of 2 years at this point, the James Webb Telescope has been homing in on the most profound mysteries of the universe. What's more, it has proactively identified an entire scope of designs that, according to our understanding, shouldn't exist at all. Here, where our current models have reached their limits, a hypothesis at last becomes an integral factor. The English physicist and Nobel Prize winner Roger Penrose as its most renowned advocate. No, the Big Bang was not the start of everything, but just the dangerous change between two grandiose parts. As a matter of fact, Penrose is convinced that the universe has forever been dependent upon a cyclic pattern of destruction and resurrection. And incredibly, the most recent discoveries now even suggest that he is right. But what about the mysterious selling points, which, according to Penrose, epitomize the remnants of a past universe? Limitlessness is limited, well, basically for us. Although many specialists suspect that the universe is endless, from our natural perspective, we are only able to see an imperceptibly small part of the whole. Our circular field of vision is suitably referred to as the observable universe, and it includes the region from which information could have arrived at the Earth since the Big Bang. Given that the Big Bang took place 13.8 billion years ago, one may believe that the distance to our normal view, the so-called event horizon, is also 13.8 billion light-years. But that is false. After all, the universe, that is, space, has been constantly expanding since the dawn of history, which actually means that distances previously covered have been stretched reflectively. The distance to the perception horizon is, at last, estimated at 46.3 billion light-years. What is exciting here is the truth that each point in the universe has its own detectable universe. In other words, if there is a civilization billions of light-years away out there, it can see a piece of space that will forever stay the great unknown to us. Because of these astronomical signals, specialists can hypothesize about what lies dormant outside our field of vision. While many scientists believe that the designs there relate to those in the nearby universe, others estimate that the invisible depths of space are even more peculiar than we can imagine. Anyway, the black hole that the James Webb Telescope added to the star graphs a few weeks ago was also much more peculiar than we could have ever imagined. Dedicated with the scientific name Leaf 568, the gravity beast had already existed for 1.5 billion years after the Big Bang. However, despite this, it evidently consumed matter multiple times faster than is hypothetically possible. But let's be clear, this mysterious Webb discovery in no way denotes a galactic exemption. Instead, it corresponds to the new, baffling design we now know about, an entire series of black holes that just appear too massive for their early development. These include the quasar, a functioning cosmic core called J120+0641. Which dates from the grandiose sundown period. But it already weighs more than 1 billion solar masses, to the specialists' alarm. However, a closer assessment with Webb's mid-infrared instrument, MEI, failed to uncover any phenomenal feeding system. Thus, it just so happens that we simply don't know how a very massive black hole could have been fully developed when the universe was only 5% of its current age. Since our current models can no longer make sense of the infinite premature infants of the recognizable universe, new approaches must be considered. And the reality that these occasionally have the potential to reform how we might interpret the universe is shown by Sophie Kidman's comments. She found out if the shockingly enormous dark openings could have formed from structures that existed indeed, even before the Big Bang. The astrophysicist from the University of Cambridge answered the astonishing thing about this question is that nothing is precluded. Certain people say that the mass of dark openings we have now viewed as in the early universe probably been formed by an immediate breakdown. There are a few publications that suggest the perceptions demonstrate this. If dark openings develop proficiently, they have barely enough time to create from an extremely light seed. Yet, despite the fact that Kudmany underlines that this model is only one of many clarifications, it gives a heavy reason, specifically that there was, in fact, something before the Big Bang and hence for our universe. The cyclic model, the end as a beginning. The way that current cosmology has arrived at its limits in a large number of regards is also demonstrated by the Webb revelation, which set off the galactic emergency. In any case, after all, as soon as February 2023, the word had already gotten out that there were 6 unthinkable systems out there that were as gigantic as the Milky Way seems to be today, a good while ago. Anyway, since this surprising finding was an unmistakable inconsistency to our hypotheses about the density of matter in the early universe and about universe development, the peculiar objects immediately acquired the epithet universe breakers. And obviously, some universes in the youthful universe were considerably more effective at changing gas into stars than others. Essentially, that was the decision arrived at by an examination group from the University of Geneva, who concentrated on 3 cosmic heavyweights, 2 known as the red beasts, in view of their appearance in the Webb pictures. As indicated by our speculations, cosmic systems structure relatively slowly inside radiances of dark matter. These catch particles and atoms and bound structures around them with their gravity, from which cosmic systems eventually grow. However, while, generally speaking, only around 20% or less of the caught gas is changed over into stars, the corresponding extent in the case of the red beasts is an incredible 50%. But indeed, the way in which the design survived this about 1 billion years after the Big Bang remains a mysterious problem in stargazing for the time being. All we know for sure is that something must have occurred in the earliest cosmic parts that prepared for the astounding growth of galaxies. But what if that's not true? What if the foundation for the advancement of the universe was not laid with the Big Bang, but before that? Well, then we would have arrived at the center of an amazing theory that Roger Penrose has been advancing for quite some time. Revered with the Nobel Prize in Physics in 2020 for his examination on dark openings, the English mathematician and physicist is convinced that the universe is repetitive. Therefore, Penrose doesn't see the Big Bang as the frequently cited start of literally everything, but simply as the transition between 2 ages of 2 vast life cycles. Consistent with the adage, each end is followed by a fresh start, the universe would continue to expand until all matter has deteriorated and become light. As indicated by Penrose, this limit environment, in which nothing has a time or space reference to each other, will inevitably lead to another Big Bang over and over again. As a component of each inestimable finale, the dark openings will also dissipate totally and consequently deify themselves in the following universe as a unique leftover that vouches for the presence of the past universe. But that's not all. Penrose claims to have found exactly these obvious follows in the astronomical microwave background exhaustively. This all refers to various round spots that should be visible in both the Planck and the WMAP satellite data. And just to explain, the inestimable microwave background radiation, or CMB for short, is an artifact from the beginning of the universe made close to 380,000 years after the Big Bang during the recombination epoch, still saturating the whole universe today. To understand why the discovery of alleged selling points could be so huge, we must first understand that the cyclic model sets cosmological expansion before the Big Bang. This generally refers to a period of incredibly fast development of the universe, in which the universe encountered an unmatched growth spurt right after its creation. But assuming that we now place this inflationary development before the birth of the universe, we are dealing with the aftermath of the dramatically extending fate of a previous age. On a basic level, the transition from age to age is sound from both a numerical and an actual perspective. Despite the fact that very monstrous dark openings represent an exemption, since these would have nearly totally absorbed the system groups in their current environment toward the finish of an inestimable part before them totally vanish into Hawking radiation, they would take the whole emanated energy with them into the resulting universe as a single Hawking point. The photons delivered in this cycle would thusly be tracked down in an extending area, which, anyway, possibly becomes apparent when it finally shows up in the microwave foundation radiation of the new universe. On paper, such a selling point would look like a plate the size of the full moon, and practically speaking, the data referenced have uncovered exactly that in the microwave foundation. To be more exact, the unpropitious spots relate to products of the normal CMB temperature variances. And, in fact, specialists had accepted that such highlights would have been totally cleared out by cosmological expansion. Considering this energizing discovery and all the cosmological irregularities uncovered by the James Webb Telescope, Is it conceivable that our reality doesn't relate to the one universe by any stretch of the imagination, but only to the ongoing cycle? Well, that is exactly the focal point of the cosmic discussion, which is far from over. But regardless of whether the universe truly is dependent upon a timeless pattern of destruction and resurrection, some fundamental questions remain unanswered. What, then, marked the starting point of the cycle? Is there such an amazing concept as a starting point in infinity at all? And will humanity one day prevail in completely grasping the world in which it lives? Well, who knows? But definitely, you see totally that you should now click to approval and the subscribe button if you never want to miss another new video from us again. Go ahead and become a piece of our community to keep up to date from here on out. We'll see you soon.